Okay, dear student, we are going to study about the chapter number 12, wave and sound. Now our topic is echo. What is echo? The sound here after reflection from a surface within 1/10th of a second is called echo. The reflection of sound when we are speaking or clapping, our sound waves strike with the barrier and return back. If this sound return back within 1/10th of a second, then it will become an echo. So, for the learning, the distance of an echo is 17 meter, means the minimum distance for producing an echo, that is 17 meter from the barrier where the sound wave will strike. Number 2, the persistence of sound in our ear is 1/10th of a second, means the sound which we heard, it remains in our ear for 1/10th of a second. If the same sound return back within this time, both the sound reinforce each other and produce echo. For the distance, we can prove that the distance of an echo is 17 meter. Now, this is a cliff and this man is clapping here. We have to calculate this distance, and the speed of sound is 340 meter per second at 15 degrees centigrade. At 0 degree centigrade, it is 330 meter per second, mean 330 meter per second. When the temperature is increased, it is also increased 340 meter per second. And the returning time of the sound of clapping is 1/10th of a second. We have to calculate this distance, that is elapsed distance, mean time for going, distance for going and coming. This is double distance. It is called elapsed distance. Look at, we know that V is equal to S upon T. In third chapter you have studied, or S is equal to V into T. So here S is 2T and velocity V is 340 meter per second and time T is 1/10 of a second. Now S is equal to ET. By putting the values, instead of us we write 2D is equal to, instead of V 340 and T 1/10, 0 and 0 cancel, so it becomes 2D is equal to 34 and D is equal to 34/2, that is 17 meters. So it is the distance for an echo. Next topic is reflection of sound. Like light rays, they strike with the barrier and bounce back. Likewise, sound waves bounce back when struck to any barrier or any surface, obeying the law of reflection of light, that is angle I is equal to angle R. It is known as reflection of sound. Now we can explain it. How is it obeying the law of reflection of light? We can take this hardboard and hold PVC pipe having same length and same diameter in front of the hardboard, and in between the PVC pipe we place a cardboard. Here in front of the face of the one pipe we place a clock, and other pipe we place our ear for listening the click sound of the clock. We listen the click sound of clock only when the angle of the pipes is equal with respect to the cardboard, mean angle of incident, this one is incident angle and this one is reflected angle. When both the angles become same, then we listen the click sound of clock. So it is proved that reflection of sound also obey the laws of reflection of light. That is, angle I is equal to angle R. Next, you can write in this few lines, take two same PVC pipes and hold them in front of hardboard as in figure. Place clock near the face of one pipe and air near the face of other pipe. We will hear the click sound of clock only when the angle of the pipes is equal with respect to the cardboard. That is, angle I is equal to angle R. Hence, reflection of sound obeys the laws of reflection of light. Next topic is application of reflection of sound. First one is whispering gallery. In Shahjahan Mosque, Thanta, there is a whispering gallery. When whispering in the court is heard in the mosque, means when 2 or 3 persons or more persons are whispering in the courtyard, their sound is heard inside the mosque. So it is due to the reflection of sound in the whispering gallery. Now, stethoscope. Stethoscope, it is also used by the doctors. It is the application of reflection of sound used by the doctors. In its tube, sound heard beat is reflected and heard by the doctor. Means this is a whispering tube, and here heartbeat is received from this dot and it is reflected through this tube, and in the ear doctor can listen the heartbeat of our body. Next, whispering tube. Whispering tube is the application of reflection of sound in which sound waves reflected and propagate from one hand to another hand and heard without losses. So this one is whispering tube. When the sound waves enters, they are reflected inside the tube and propagate, and go from one end to another end and listen by the ear without any losses. So these are the applications of the reflection of sound. In next topic we will study about